from FPT Infrastructure. They've been a longtime member of the Bridge Preservation Partnership, so let's welcome Marcy.
Hi, everyone. Thanks for the time today. Really appreciate the opportunity. FPT Infrastructure originally started out primarily in pavement preservation, and with adding some materials to the portfolio, we're doing full bridge deck restoration now. So what I wanted to talk about today is probably a little less about specific materials and technologies and more about the processes that go into this, working with DOT owner agencies, consulting engineering firms and architects, contractors, and other material suppliers, how we all interact to avoid some of these major pitfalls on bridge deck restoration. So we'll do this. Okay, show of hands. Anybody ever have a bridge deck restoration project go bad? Ever? Come on, all right. We know it can happen. There are a lot of things that can go wrong. This is typically what we go out to fix, but sometimes this is what happens when we're out on the project and it doesn't go well. So how do we avoid the pitfalls? So the three main pitfalls to avoid. Poor communication and specification development. This is something that we see a lot, and it's multi-way communication that doesn't happen. Lack of project discovery and documentation. We just don't know the details of the project very well. Things that happen on site out of our control, sometimes in job phase handovers. What can we do as material suppliers, owners, contractors, consultants to work together to overcome these pitfalls? And then I want to share a high success project where just about everything went right. So the first pitfall, poor communication. Sorry, I am not synced up here. Why are we working on the deck? What's really going on with this project? If the specification that we've developed isn't matching what's really going on in the project, we can encounter these pitfalls. Do we understand the interactions between materials? And if we discover that there are problems, do we know who at the DOT or with a consultant or with a general contractor, who do we talk to about work stoppages and moving this project forward? On to the first example. Generic specification at a state that I won't name. The state developed their own spec for a thin polymer overlay to treat a number of bridges in the state. When our contractor got out on the project, I happened to be there the first night, we noticed some really significant cracking in the deck, half-inch cracks. And the DOT representative on site said, wow, if you think this is bad, you should see what's going on underneath the bridge. You know, we're having many heart attacks, but the overlay was bought and paid for. We moved forward with it. It was going to address the clear issues that were going on, but long-term, it probably wasn't the best solution. To make things even more fun on this project, the new overlay was installed, and I got a call from the contractor about 2 weeks after we did the last bridge of a 4-bridge project, and he said, hey, the striper's here and they want to grind 80 mils into the overlay to put striping down on this. Is that a problem? Well, you know, I don't know. The DOT just spent $1 million on an overlay and you want to take up a third of it. It's kind of a problem. So we had a material interaction that should have been discovered at specification time. So kind of a problem. What can we do to mitigate this? Owners, inspectors, engineers, let us know as material suppliers what's really going on, because this is a project that, had we really gone out there, done a pre-inspection, understood the extent of the cracking, the movement on the deck, we probably would have said, number one, use a system with a true membrane. This thin polymer overlay is not the right solution for this bridge. It may be for the rest of the bridges in your area, but on this particular one, you need more. Check for material interactions. Don't invest in a product that you're then going to take some of it off of the deck. Communicate. Who do we talk to at the DOT to get a specification changed or identify interactions and raise concerns? And then as material suppliers, we really try to be upfront and clear about what our solutions can and can't do. We do read specifications very carefully, and we look for these material interactions up front. And then we train our installers to also watch for these things when they're on projects. So some deliverables that we'll do, we try to get a pre-design site visit, and this is, again, pre-specification. We try to meet with the DOT so that we really gain an understanding what they want out of this project. And these are not really big, high-impact projects. These are small, sometimes in rural communities. They're basic overpass bridges, but there's a lot that can fall outside of that general specification. A custom scope of work document for that particular location, and then a contact list. We supply our manufacturing contacts, our QC contacts, and everybody at the contractors group who's going to be on that job site or accessible to help. Pitfall 2 kind of extends into that communication phase, but this is a little bit more of, we've got the project, what are we planning for when we go out there? And this is told from the waterproofing supplier point of view. Make this list your own. We really want to know what's going on with the substrate, what's the quality of the deck, what's chloride content, how copious is the cracking. We want to know if there's a prior waterproofing system on that deck. Is it going to be removed? How far does it extend beyond the deck and potentially into pedestrian access or upturns? What are the movement joints? What are we tying into? Is there drainage on this deck? Putting a waterproofing system down and not paying attention to the details can be a real problem. The contractor will get out on the job site, see things that weren't in the plans, and not know how to handle them. Here's an example. The contractor went out to do the deck assessment on this particular project, and this project was a bus lane over top of a highway system. So adjacent to it, and you can kind of see in this bottom photo, there's a hot rubber waterproofing system. That did extend all the way across the pedestrian walkway and onto the bridge deck, but when they prepped the bridge deck, they took it off. The problem was when they overlaid the concrete on the pedestrian slab, there was no drainage, and so water was continuously seeping over the hot rubber platform and onto the deck. We make an MMA material. It doesn't react well with water. That deck needs to be really dry, and even on sunny days, water was seeping onto the deck, and it was never disclosed on any of the plans. So we had to develop a mitigation plan for that. So project documentation, what we want, site images. The drawings are great, but the drawings don't show us where the cracks are. It doesn't show us the existing waterproofing system. We will provide detailed drawings specific to every project. We'll provide the owner and the consulting engineer, whoever is going to approve, what the waterproofing system looks like at an upturn, what it looks like at an expansion joint, what it looks like at a drain system, and we want the owner to sign off that this particular treatment is going to work and they know it's going to happen. And then we'll give those details to our contractors so they know how to install properly. We'll do a deck assessment. We ask our contractors to do it if we're not on site, and we keep a job quality control sheet for every night or day or whatever the work is being done. We're documenting environmental conditions, what's the temperature, what's the substrate temperature, what's the humidity level, so that we've got good quality control around that project. So these are just some of the examples. Here they're getting ready to do adhesion testings. We'll do overhead shots. Google Earth is great. It's my new best friend. And Google Earth documentation now, those photos typically are within a 6-month window of when you're going to be on a project. So if it's really costly to go out and do a lot of pre-work, we can pick up images and do a lot of our markings from those. Details. These are a couple of generic ones that I pulled, but we're showing how to treat deep cracks before you put the waterproofing system down, how to overlay an expansion joint system and the materials that will go into that. Checklists and forms, we have a lot of them and we change them every time we have a project because we learn something new. We want to continuously improve what we're doing. So pitfall 3, you get on a job site and stuff just happens. The project we went out on and found out that the milling machine, the driver drove into the sidewall on the bridge and it broke the sensor off on the milling machine, and the milling machine just ground down all the way to the rebar. The picture on the left is the trough that they chunked out that had to be filled, cured, and ready to seal before we could overlay the waterproofing system. On the right-hand side, that deck was over-prepared. Typically, we need a 3 to 7 surface profile. This was, in some areas, 9 or 10 with a lot of chunks left behind. I'm thinking about Blake's presentation and making sure everything is cleaned off this deck. This was not ready to waterproof, and it wasn't our contractor who was doing the work. It was somebody else that got subbed by the general. They just didn't read the instructions. So another thing, what do you do about this when you show up and that's what it looks like? We do request and obtain a contingency plan from our contractors. We train them ahead of time. We provide those detailed drawings. We tell them to buy more material than they need. When you get out on a job site and that deck is over-prepared, it's going to consume more material. So we want to make sure they have that on hand. As owners or consulting engineers, whoever is project managing that job, I would ask your contractors coming out for their contingency plans. How are they going to keep work going? How are they going to deal with mishaps? We were fortunate in this prior one, when that trough got dug out, our contractor had purchased some MMA patching material that cured in an hour and was compatible with the MMA going over top of it. So we always recommend have that patching material on hand. So it was a lot of bad stuff that happened. I'm going to close with some good stuff that happened. This was a project up in Calgary. Construction there is always dicey because the climate's kind of rough. Generally, we can work from April through September if we're lucky, and we got really lucky on this project. But we were also very purposeful on this project. So the Glenmore Dam is at the end of Glenmore Reservoir. It is a drinking water source for the city of Calgary. The city of Calgary owns and operates this dam. Why did this go so well? Well, because we had open communication and collaborative work from the start. So we knew the why of the project, and that was to provide waterproofing on dam to protect some mechanical rooms and offices that were underneath that bike pathway. But the bike pathway connected park systems on either side of the reservoir. So there was we needed a pedestrian and bike surface that was appropriate. The materials, they needed to manually apply this. Again, this was a drinking water source, so we weren't going to go out and apply any type of membrane on here. We had to be really careful on how the deck was prepped and the blow off from the concrete. So everything had to be vacuumed, everything had to be really contained. Aesthetically, it was really important for the city and the architect to have a finish to this bike path that blended in with the natural environment. So Dale's here from Armourstone. Dale was involved in this project, provided a lot of communication, not only about the look and feel of the aggregate, but also how durable it was going to be. This is a snowy area. They do a lot of brush brooming, and we needed to make sure that the aggregate and the seal coat that we put on top of it was going to stick and was going to last for this purpose. Communication was multi-way. I was part of email exchanges between the City of Calgary, Placecrete, which is one of our longtime applicators up in Canada, Armourstone. We were all talking all the time and all sending information back and forth. So the discovery in this, Placecrete was on the job site with our manufacturing representative. We had really limited access for materials and equipment. So typically we can bring a very large box truck or a very big open bed truck to bring materials in. This is a bike path. It's not wide enough. You can't bring motored equipment out here. So they had hand carts to move pails of material in and out, and that was all part of the discovery documentation. We knew what the deck condition was. Cracks were pre-treated, especially in the office areas, and we detailed the joints and drains that were present on the deck. Once we were there, Placecrete was there installing. They're a 10-year installer. They just know what they're doing. They know how to handle obstacles. They prepare really well for projects. This, again, continuous communication throughout. And I will say, for Canada, we just got really lucky. We had blue skies and sunshine for the entire week of this install. Everything went very well. So in the end, this is a really high success project. We get to brag about it. Armourstone can brag about it. Placecrete brags about it, and the City of Calgary loves it because it's a really high visibility project. It connects their park system, and they can talk about preservation of the drinking water system. So what can we do at the end? Well, communicate. You know, every organization that ever surveys their employees says, what's wrong with us? Well, we don't communicate enough. It extends everywhere, and the basis of good project management is communication. Be open, be clear, be upfront. We all want successful projects. I don't want to go out and put my solution on a project where it doesn't fit. And so we as material suppliers need to vet what we're bidding on. I think owners and consulting engineers need to be really upfront about what the problems are to make sure the solutions are right. We don't waste money, we don't waste time. Be problem solvers. If you can't solve the problem, find someone who can. We can't fix everything, so we'll refer to somebody else if we can't. Set expectations, know what the project requirements are, and be visible and advocate for the success of the project. If our contractor had not contacted us and said, hey, they want to grind off the system, we just worked our butts off to get in, they would have done it. Eventually, that system would have cracked prematurely. There would have been water and chloride intrusion, and it probably would have broke the system up. But everybody was proactive. Everybody stopped and said, wait, this is a bad idea. So this was a lot about process and not a lot about technology. So I hope it hit home with you. I hope you get some ideas out of it. If you want any more information about what we do for continuous improvement, stop by and see me. Okay, thanks everybody.
This isn't yours, right?
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.